Hi, and welcome to my poster. My name is Adam Kirkwood, and I'm a first-year PhD student at Laurentian University in Sudbury, Ontario. And here's a brief look into my poster. My poster is on landscape change in a thawing north, looking at observations of permafrost thaw and how this relates to landscape scale changes. This work takes place in the Hudson Bay lowlands, and that's what you can see in the map here. The Hudson Bay lowlands is the world's second largest northern peatland, and it's also host to North America's lowest latitude continuous permafrost. The research question that I'm trying to answer here is whether we can take large-scale satellite imagery, such as the large collections of Landsat data that's publicly available, to calculate indices and combine them to try and interpret where areas have been affected by permafrost thaw. The purpose of this is because there's very little information on permafrost conditions in many areas of northern Canada, and this information can hopefully be used to provide a method to assess where areas might be vulnerable to thawing permafrost. To do this, we use Google Earth Engine to calculate a few different indices, including normalized difference vegetation index, normalized different water index, and to also calculate landscape classification based on the spectral signatures of the remote sensing data. Then once all of this data is calculated, we combine these layers to see if there's been significant trends and if there are any areas where there's been change in all three of the indices. Then after finding these areas, we'll use high resolution satellite imagery to kind of spot check these areas to see if we can visually confirm the presence or the absence of permafrost thaw features. My results are only preliminary, but we see that there's extensive greening trends across the Hudson Bay lowlands, and this is consistent with the rest of the Arctic. But unfortunately, just these greening trends alone could not be used to identify areas where permafrost thaw was abundant. But if we look at these figures, we can see that there's extensive greening near the community of Fort Severn, with moderate to extensive patches of greening. There's also moderate to extensive patches of greening along the Severn River, and one interesting thing that we can see here is that there's these three mass wasting features in an area of extensive greening. However, we're not yet sure if these mass wasting features are related to the extensive greening, so there's definitely further work to do in this area of determining the potential triggers of these mass wasting features, and maybe if they're related to this greening. The next steps in my PhD project are continuing with this remote sensing data and calculating some of the other indices. And once I've done this, I'm going to look on focusing on what the impacts of thaw are, which includes assessing the permafrost conditions where we found there was these significant changes to the surface. Then I'll also be elucidating the structure of these mass wasting features and what their triggers are, and determining whether it's related to increased greening or warming temperatures or maybe higher river flows and more bank erosion. And then finally, I'm going to look at the impacts of this permafrost thaw on biogeochemical cycling of mercury and carbon, and how this may change the structure of the microbial communities that perform these cycles. So that's a very brief introduction to my poster, and if you'd like, there is another QR code where I go over the whole poster, and I'd love if you would take a listen, and then you can provide me with any comments or email me with any questions. And hopefully we'll be able to talk about this in person one day, but until then, be safe and enjoy the rest of the conference.